So I wanted to have a version of BASIC to run on my new Z80 board that I built. And for retro computing reasons, I decided I want Altair BASIC. And I found an original copy of Altair 8K BASIC on cassette tape. Now, there are versions of this available in file format on various websites, but as I understand it, the copyright is still valid for Altair 8K BASIC. And being a stickler for stuff like that, I did not want to use any copied version of Altair BASIC. I wanted an authentic copy because then I would feel that I would be free to use it. So it actually cost a bit of money to get this tape, and they seem to be rare. I see on image searches that this does look like an actual Altair cassette tape, that it's not a copy that was made back then, it's an original. And what's interesting about this tape is it may be from a limited production run, like an early run of these tapes, because there are also, as you can see, the label is a dot matrix printed label stuck on a consumer quality cassette tape. And it appears that there are other versions of this that look just like this that came out on the same Maxell C46 tape, LN. It's an LN tape. So I feel it's legitimate. But you can also find images for tapes that have MITS copyright on them for BASIC that are on offset printed labels that are not stuck on over a consumer tape. These are mass-produced tapes. So it seems to be from an early run, and if you flip it over on the back, I don't have a photo of it, it's hand numbered in pen which copy it is out of the number of copies in the production run. So it appears to be a handmade tape, but it also appears to be a legit tape. So I wanted to say that because you'll see I'm doing things in the video where you might say, well, why are you doing it this way? Because you could just grab the source code and edit it and make it work for you. I don't want to do it that way. I want to take an original tape and apply whatever patches I need to apply to make it compatible with a Z80 and run it. And so that's what this project is all about. So now that we're done with the preliminaries, let's take a quick look at what's involved in getting BASIC, which is code written in 8080 assembler, meant to run exactly on an Altair with Altair I/O devices. Now, back when the Z80 came out in the 70s, we were told, hey, here's this great chip. It's backwards compatible to the 8080. It'll run the 8080 instructions, plus it has all these new instructions, plus it has other advantages. So at that point, I built a Z80 system because then I knew I could use the 8080 assembler that I had access to program the thing, because I had no idea where I would get a Z80 assembler. But if you look into it, it's not 100% backwards compatible to an 8080. It handles the parity bit differently, and for the most part that doesn't matter, so a lot of code would run right out of the box. But unfortunately for 8080 BASIC, it very much depends on doing branching based on the parity bit after math operations, and that just can't work if you run it on a Z80. So I could go into gory details about what was involved, but let's just say I made 140 bytes of patch code to patch around problems where it was testing the parity bit. I also had a patch in code to handle reset, since Altair BASIC just takes over the Altair and assumes an Altair environment, and it uses all of memory. There's no place to stick code, like to patch it in line, because it's using memory from page 0 all the way up to about 2000 hex. I had to come up with a clever way to patch in a Z80 reset routine in addition to the patches for the parity bit. But once that was done, BASIC works perfectly. So out of the box, you can't get Altair BASIC to run on a Z80, but with some patching, you can get it to run on a Z80. Now, I did get it to run on my actual hardware, but my hardware is the first board I built of the first version of my Z80, and it had some hardware problems that I was doing hardware hacks to deal with, and I tried to do a demo of BASIC running on that board, but there were too many caveats to ignore because basically my serial port was very noisy. I just did a new revision of the board, and I'm waiting for a new PCB to come in. I still can do a demo because in the development process, now aside from trying to go from tape to a WAV file to binary, let's say that's done, and I did that with software. Then I had to patch BASIC. But in order to know that my patches were working and to be able to tell the difference between the patch not working and my board having problems, I employed the use of emulators. So I have two emulators that I use. One is an 8080 emulator, one is a Z80 emulator. They both are written in C. They are very simple and easy to extend. So I was able to take the 8080 emulator and make it work for the ports that Altair BASIC expects out of the box so that I could get console I/O to a terminal window. And I was able to enhance the Z80 emulator to look like my Z80 board so I could use it to do proof that things will run on my Z80 board if my board actually works. Also, the Z80 emulator was important to find and verify that I found the problem spots in 8K BASIC that needed patching. So I can run a little demo here because I think it's interesting of BASIC running in a Z80 emulator, and just take it from me. It runs the same on my board, except my board had some trash character issues. So I'm going to run it because there's interesting things that I found while running it. So the first thing that BASIC does is ask you what memory size to use. Now, they let you type a number here. It can be any number up to 64K. The idea is, let's say you have a certain amount of memory and you want to reserve some memory for assembly language routines. You can type a number here and BASIC will use that as its maximum memory bound. Or you can hit enter and it will run through memory starting at the end of BASIC, writing a pattern until it hits a spot where the pattern doesn't read back. At that point, it assumes it hit non-existent memory or ROM, and it uses that for the high bound of memory. The problem with that is there's a bug here. 8K BASIC's memory sizing is very simple, and it just sets up HL to the byte after BASIC and starts incrementing and writing until it reads back the wrong value. Well, if you have a full 64K system, it will never stop. It will hit FFF, that'll be good, and it'll increment HL, and it'll wrap to 0, and it'll keep writing, and it will erase itself. They didn't expect anyone to put a full 64K in an Altair. It's questionable in 1975 if that was even possible financially or possible as far as the number of boards you'd have to put in the system. So they probably thought it was safe to assume that there was at least a ROM in there or some non-existent memory locations. What I did was patch this so that I put my patches up in the high end of the first 32K, and I have this put the high bound to the byte before that. Now, I'm running this as a 32K system because I'm doing something tricky with the high 32K. I actually have 128K on my Z80 board, and I use bank switching, but let's just say I'm using 64K for basic, but I'm only allotting 32K for basic and my patches. So if I hit enter, it'll size memory to that. But there's another interesting thing that doesn't seem to be documented. If you type A and hit enter, it prints out who wrote this thing. Bill Gates, Paul Allen, Monty Davidoff. And that's nice. And I can't see it documented in the manual. And it's possible that they had some reason that it was not documented, and I won't go into what that reason might be. So I'm going to hit enter, and now it asks for terminal width, and you can type a width in here. I haven't tried it. I usually hit enter, and it sets it to 72, which was typical. And on 4K Basic, it asks you a series of questions about what to remove. But on 8K Basic, it just says, do you want to get rid of trigonometry? And if you say no here, that you don't want trig, then it frees up some memory for you. But I'm going to say yes because I have a lot of memory. And I get about 26K free bytes after Basic takes up its space and my 140 bytes of patches. And it says Basic version 3.2, the 8K version, which is nice. And you get the OK prompt. Here's something very simple test. The first thing I tested it with is print hello world in immediate mode, and it prints it. Something that I want you to notice is all the uppercase here. So they may have assumed people were using teletypes. That was a good assumption because I was using a teletype with an Altair back then, and it was pretty common because it had the ASR 33 had the paper tape punch and reader on it. People are using dot matrix printer terminals, and some people had video terminals, primitive ones. I would call them primitive. We called them dumb terminals. They just printed text to the screen. But they either, to save space, didn't allow lowercase keywords and lowercase variables, or they assumed that most people didn't have lowercase because a teletype didn't have lowercase. So all the keywords and variable names have to be in uppercase. It will let you put lowercase in strings. That's nice. So what I've done here to save a lot of headaches between playing with the shift key and forgetting, and playing with caps lock and forgetting to turn it off, is I wrote a terminal emulator of my own that basically emulates a teletype. So right now, even though teletypes didn't go that fast, it's emulating a teletype at 9600 baud that prints ASCII characters, 7-bit characters, and it automatically uppercases things for me. If I hit shift, I actually inverted the sense of the shift key. So if I hit shift and type alphabetical character, it'll print lowercase. Another thing to note, and the reason why I needed an emulator to do something about the printing the characters, is 8K Basic, to save a byte, they did not null terminate the string tables for keywords. They did not null terminate any string that they print because they wanted to save a byte, I think. They didn't put a $sign at the end, which was also a thing that we would do back then. No, they didn't have a length and then the string. No, that takes a byte. What they did was, figuring that everyone's printing to ASCII terminals, which is 7 bits back then, and really it still is 7 bits, but we can do 8 bits to get special characters now. They would set the most significant bit of the last character high to indicate that it's the last character of a string. However, to save code, when they print this string out, they don't mask off that bit when they send out the last character. So they send out a character with the high bit set. Back then, it didn't matter because terminals were ASCII. They ignored the high bit. Some of them only took 7 bits. In my case, I'm printing to Mac terminals and Windows terminal programs, and they'll print a special character if they see the high bit set. So my terminal emulator strips off the high bit. So another thing to notice is back then, print. Suppose I didn't want to type foo. Today you would hit backspace to delete characters. Back then, that was uncommon. Sure, we had some video terminals and some video-based systems in the 70s that knew they were going to a video terminal and they would allow a backspace. But nobody that I remember allowed cursor controls on the line to edit. And for anything that knew you were going to or were likely going to a printing terminal, since printing terminals, it doesn't make sense to backspace to delete a character because you'd end up overstriking even if the terminal allowed the backspace. And not every terminal allowed backspace. We did something else back then. And what we did was use special characters where you would indicate how many characters you want to delete. So in Altair Basic, they use the convention of you hit @ to delete the whole line that you typed so you can start over. Or like in this case, I misspelled print. So I want to delete that N. So I can't use backspace, but I use underscore, and that means delete the last character. Now, you can use multiple underscores to delete multiple characters, but you got to keep track in your head where you are in the edited line, because it can get complicated when you have multiple edits on a line with underscores, and then you proceed, and then more underscores. So that's the way life was in the 70s. So let's try a simple program. I accidentally hit shift, but there's an example of getting lowercase. Altair Basic is nice. I don't have to say next I. If you just say next, it assumes the innermost for loop. Let's take a list of that. And that's the program we just typed. And if we run it, it prints it. And you can see it did allow me to use a lowercase character. Now that you've got this program written, suppose it was 100 lines long, you're going to want to save it. Back then, if you had a teletype with a punch and reader, what you would do is set up the paper tape punch to be ready to go, and then say list and start the punch and hit enter, and by listing the program out, it would punch it to the tape. Then if you wanted to read it back in, you would set it up in the reader and say new, and then start the reader going, and essentially the reader would type the saved program back into BASIC. So that was one way to save and load programs. Altair Basic, I'm not sure if the 4K version allowed it, but the 8K version definitely allows it. Had the ability to read and write to cassette tape or any kind of tape port. Basically, they write binary bytes to a port, and you could hook anything up to that port. And typically you hooked up a cassette tape interface. They had an assumption about the I/O address for that cassette tape interface, but they even say in the manual, well, we chose these addresses probably because those were the Altair cassette tape port addresses. But they said you could patch BASIC to use whatever addresses you need for your device. So I patched BASIC to just use the console I/O port because for now I don't want to build a cassette tape interface. So what happens is if I say csave and you give it a 1-character file name and hit enter, it will, this is all a csave is it dumps in a binary format, it dumps the program out to the tape port. In this case, the console port. Since I have an emulator that I'm working with, I enhance my emulator so that if you say csave A, and then instead of hitting enter, on a Mac, I hit Control W. On Windows, my Windows version, I hit Alt W, but Control W, it'll do the enter, and it will emulate receiving into a tape. So now if I say new and list, and then say C load A, and then in this case say Control R for read, it reads it back in, and you can see it came back in and it still runs. So combination of, I'll have initially, until I build a cassette tape interface, I'll have my Z80 board assume that it's working with an emulator, a terminal emulator that I wrote so that I can save programs, because I'm not going to want to type big programs in by hand. So here's a slightly bigger program. So that's more than I would want to have to re-enter by hand. Now, this program exercises a few things. It exercises string matrices, for loops, and go sub, and it proves that I can do VT100 style cursor controls. You can see on line 1005. And if I run this, what it does is animate moving a block of dots across the screen. The reason why I wanted that to work is in 1976, I wrote a basic text animation game where I did text animation to do a little space game where you shoot aliens. And I won a programming contest for that, and I want to rewrite that in Altair Basic. So that's a little demo. If you want to do something like this, if you've got a Z80 board and you want to get Altair Basic running on it, I think I've given you enough information to go on to go do your own thing now to patch it. As I said, I'm using an official copy of Altair Basic, and those apparently are getting rare, but now I'm on the lookout for an original copy of Extended Basic, because I thought that might be interesting to get running. But that's it for now.